Hello everyone and welcome back to our channel. We are thrilled to have you join us as we continue our in-depth exploration of the software development lifecycle. In our last video, we took a detailed look at the analysis phase where we examined the importance of gathering and documenting requirements to lay a solid foundation for the project. Today, we are moving forward to one of the most exciting and hands-on phases, the coding phase. This is where all planning and analysis come to life as we transform designs and requirements into actual software. We will dive into the key activities of this phase, including writing code, conducting code reviews, and performing unit tests. Get ready to learn how developers bring ideas into reality through code. Make sure to like, subscribe, and hit the bell icon so you never miss out on our latest content. Let's get started. The coding phase in software development lifecycle is a pivotal stage where the design specifications are translated into functional software. This phase allows the planning and design stages where the vision for the software is fleshed out. In the coding phase, developers use their expertise to bring the design to life, writing code that implements the features and functionalities envisioned in the design documents. This phase is marked by meticulous crafting of code that meets the predefined requirements and ensures the software operates as intended. Let us start with the writing code. First one, language selection. Developers choose the most suitable programming language based on the project's requirement, the target platform, and the team's expertise. For example, a web application might be developed in JavaScript while a mobile app could be built using Swift or Kotlin. 2. Implementation. Developers translate the design specifications into actual code using the chosen programming language. They create classes, methods, functions, and data structures to represent the software's component and interactions. Third, coding standards. Developers adhere to established coding standards and best practices to ensure code readability, maintainability, and consistency. This includes using clear variable names, writing concise comments, and following established code style guidelines. 4. Libraries and frameworks. Developers leverage existing libraries and frameworks to expedite development and streamline code. These reusable components provide pre-built functionalities, saving time and effort for developers. Code review. What is the purpose of code review? Code reviews are collaborative process where developers examine each other's code to identify potential errors, inconsistencies, and the security vulnerabilities. This process helps improve code quality, maintainability, and adherence to coding standards. What are the methods? Code reviews can be conducted using various methods. 1. Pair programming. Two developers work together with one writing the code and the other one providing the real-time feedback. Formal reviews. A structured process involving a group of developers who examine the code systematically. 3. Tool-assisted reviews. Utilizing code review tools like GitHub, pull requests, or dedicated platforms, developers can track changes, leave comments, and collaborate efficiently. What are the benefits of code review? Code reviews offer numerous benefits. 1. Improve code quality. By catching errors early, code reviews help produce more robust and reliable code. 2. Enhance knowledge sharing. Reviews foster knowledge transfer within the team, improving the collective understanding of the code base. 3. Reduce defects. Early detection of issues significantly reduces the time and effort required for bug fixes later in the development cycle. After coding and code review, next step is the unit testing. The following steps are involved in the unit testing. 1. Test case design. Developers create comprehensive test cases that cover various scenarios including positive and negative cases to ensure all functionalities are thoroughly tested. 2. Test execution. The test cases are executed automatically, validating the behavior of the individual modules or units of code. This process identifies any discrepancies between the expected and actual results. 3. Test reporting. Detailed reports are generated documenting the test results, any identified errors, and the overall code coverage. This provides insights into the code's quality and identifies area requiring further attention. After unit testing, our code is ready for integration testing. What are the steps involved here? 1. Module integration. Individual modules or components are integrated to form a complete system. This involves connecting the different parts of the application and ensuring their interoperability. Second, testing interfaces. The interface between modules are thoroughly tested to verify the data is exchanged correctly and there are no communication errors. 3. System level testing. The integrated system undergoes testing to ensure it functions as expected, handling various inputs and outputs and meeting the overall system requirements. Code debugging and troubleshooting. Issue identification. Developers use debugging tools, logging, and monitoring techniques to identify the root cause of bugs or issues reported during the testing or by user. Root cause analysis. Through careful analysis, developers determine the specific line of code or configuration issue responsible for the problem. Developers apply appropriate fixes, modify code, or update configurations to resolve the identified issue. Regression testing. After implementing fixes, regression testing is conducted to ensure that the changes have not introduced new bugs or affected existing functionalities. Documentation. Code comments. Developers write concise and informative comments within the code to explain the logic, purpose, and functionality of different code sections. These comments serve as a valuable references for future maintenance and understanding. Technical documentation. Detailed technical documentation is created to provide a comprehensive overview of the software's architecture, design, implementation, and usage instructions. This documentation serves as a reference guide for developers, testers, and the other stakeholders. User guides. User guides are written to explain how users can interact with the software, navigate its features, and perform specific tasks. Clear and concise user guides improve user experience and reduce the support inquiries. Continuous integration and delivery. Continuous integration. Automate the process of integrating code changes into a shared repository frequently. This involves automated building, testing, and deployment of the code, ensuring that any new code is compatible with the existing system. Continuous delivery. Extend CI by automatically deploying new code changes to production environments. This allows for faster releases and reduces the risk of manual errors during deployment. With this, we are concluding today's session on coding phase of SDLC. If you are liking our contents, please do share our channel with your friends and family. Also, please subscribe our channel and do not forget to press the bell icon. Thanks for watching Ankhi Educare. We will come up with new videos shortly. Until then, thank you so much. Goodbye and stay tuned.